Okay guys, so this is the second part of my Unit 1 test from last year. So I'm going to begin with question number 14. During which period did the Akkadian orogeny occur? So the Akkadian orogeny, anytime they talk about orogeny, that's mountain building. Orogeny is mentioned on your reference table with mountains. The Akkadian orogeny is right here. If you follow that over, it is during the Devonian time period. So answer is Devonian. Number 15. The diagrams below represent two different geologic cross-sections in which an igneous formation is found in sedimentary rock layers. The layers have not been overturned. Which statement best describes the relative age of each igneous formation compared to the overlying sandstone bedrock? So I'm going to read through all of them and see which one best fits. In both A and B, the igneous rock is older than the sandstone. This is the sandstone, the dots. This is the igneous rock. You can see in cross-section B there is no contact metamorphism. So in this picture, the igneous rock is actually older than the sandstone. It came above the surface, cooled down, solidified, and then sandstone formed afterwards. Whereas this one, the sandstone was once here. The igneous rock intruded, touched the sandstone, touched it, contact metamorphism occurred. So it's not A. B, in both A and B, the igneous rock is younger. That's still not true. In A, the igneous rock is younger than the sandstone. And in B, the igneous rock is older than the sandstone. That's what I just told you as I went over this. Number 16. Let me just... It says, which sequence of New York State Index fossils shows the order of the organism living on Earth? So, if you come here, find the index fossil. I'm going to just pick this one to start with. So that trilobite is B. He lived in the Ordovician time period, B. So, Ordovician. Coelophysis lived during the Triassic. This fish-looking thing is R. It lived during the Devonian. That's the time of fish. And this thing, the mammoth or mastodont, it was O. It lived during the Quaternary. So we know that this mastodont was at the top of our reference table, so it must be the youngest. So it has to be one of these options. Coelophysis was Triassic. It did not come before these trilobites. These trilobites went extinct before the dinosaurs. So we can circle A. Number 17. Which two types of organisms both survived the mass extinction that occurred at the end of the Permian? Oh, I'm getting blurry, sorry. Let me just fix that for you. Sorry. So the two organisms that survived the mass extinction that occurred at the end of the Permian, anything that's bar continues. This is the end of the Permian, the mass extinction right here, 251 million years ago. this mass extinction, anything that has a bar that goes beyond that line survived. So out of all of these, I know placoderm fish didn't even get to that point. I know trilobites didn't get to that point. So anything that has placoderm fish or trilobites didn't exist. The other thing that went extinct were Eurypterids. Eurypterids. So I know that's not the case. But vascular plants and corals. Corals, vascular plants, their bars continue up the reference table. So that would be your answer. Number 18, according to the fossil evidence, which sequence shows the order in which these four life forms first appeared on Earth? So first would have been something in the ocean. It's always something in the ocean first. So if you look through here, you can see that the first types of fishes occurred during the Cambrian. Fish are actually going to be before amphibians. So it kind of goes in a sequence. It goes fish, fish. Then you would start to get amphibians, and then reptiles. So you're looking for that sequence. Fish, amphibians, reptiles. Insects were before the amphibians. Number 19, a whalebone that originally contained 200 grams of radioactive carbon-14 now contains 25 grams of carbon-14. How much carbon-14 has passed since this whale, or how many half-lives have passed since this whale was alive? So after one half-life, it would have 100 grams. After 2 half-lives, it would have 50 grams. After 3 half-lives, it would have 25 grams. So 1, 2, 3 half-lives. Number 20, I talked about in the video yesterday. How in the geologic timescale, humans are close to zero. Most everything that we have record of has occurred in this little space right here. Okay, 500 million years. This is formation of the Earth. Remember when we colored our reference table, which seems like so long ago, we colored this yellow part as being 90% of geologic time, but we didn't really know much about it. So this part right here, this entire part right here is pretty much Precambrian. That's that yellow part in your reference table. It's asking you when trilobites went extinct. Trilobites are one of the most famous life forms to ever live. They lived longer than any type of mammal or dinosaur on this planet. Trilobites are right here. They went extinct about 251 million years ago. If I look at this, 251 million years ago is like right here. It's really close to the present. You have to remember most of what we know, any life forms, is up here. And dinosaurs would have gone extinct here on this line, and humans would be right here. Okay, so A is your answer. Be careful with these graphs. They're deceiving because you think, okay, trilobites, I don't even know what that is. I don't know, when it existed. It's old, it's prehistoric, it's got to be all the way down here. But you got to remember, most of the life on this planet didn't exist until like this part, this small sliver. 21. An igneous rock contains 10 grams of radioactive potassium-40 and a total of 10 grams of its decay product. During which geologic time interval was this rock most likely formed? If it has 10 grams of potassium-40 and 10 grams of potassium-40's decay product, let me just remind you how to find that. The decay product is right here. Potassium 40's decay product will go with argon. So argon. So it's probably started with 20 grams and now it's 50-50, right? Because if I had 20 grams of potassium 40 after one half-life, it would be 10 grams of potassium 40 and 10 grams of argon. So then it's asking, when did this exist? This is one half-life. If potassium 40's gone through one half-life, that's 1.3 times 10 to the million years, or 10 to the 9 years, which is 1.3 billion years old. Okay, so potassium 40's half-life is 1.3 billion years old. 1.3 billion is going to put you in the Proterozoic. Okay, that's like right about here. It's going to put you in the Proterozoic. So if you look at the answers, it says middle or late Proterozoic. I would say 1 billion is late, so it's a little bit more than 1 billion, 1.3 billion. So one middle Proterozoic. Middle Proterozoic. 22, base your answer on the geologic cross-section. Which geologic event occurred most recently? The last thing to happen. Okay, so most recently, sometimes people get a little confused with that wording. Most recently. What happened most recently? If I look through everything here, I know the top layer occurred most recently and whatever cuts through everything. So C is most recent because it cuts through everything. This fault cuts through everything. 23. According to the graph, what's the half-life of the isotope? So at 50 grams, it's at 100%. At half of that, 25, it's going to be about 200 years. I just went half of the graph to see where it went down half. If this was 100, I'd go down to 50. If this was 300, I'd go down to 150. I'm just going down to half, following over where it hits the line, and reading the time. Number 24. Which two elements are most useful in radioactive dating of recent organic remains? Anytime they talk about recent and organic remains, it's carbon-14. Carbon-14, and its decay product is nitrogen. And then 25, what characteristic appears to have, which fossil appears to have the best characteristics of an index fossil? So an index fossil exists for a long or short period of time. An index fossil appears for a short period of time, which means it would be in one of these layers. Okay? Has to be in just one of these layers in each of these outcrops. One in each of them. The other characteristic of an index fossil is that it must appear for a large area. So it's got to be in one of these outcrops. Each of the outcrops have to have it in one of the layers. So if I look, A is not good because A occurs here. It also occurs up here and here and here and here. So I have no way of saying, okay, this rock is the same age as this rock and this rock and this rock and this rock and this rock. It doesn't work. If I look, D occurs here, here, and here. Too many places. Again, this rock is not the same age as this rock. If I look at A only occurs once. It doesn't happen over here. It doesn't happen over here. I have no clue how old that rock is. And then the last one, B. B is once here, and once here. So that would be a good index fossil because it's in a bunch of places, but once in every place. The short answer questions, 26 on the diagram above, labeled material after 2 half-lives, shading the amount of stable decay element present after the second half-life period. So this is stable decay product after 1 half-life. After 2 half-lives, it would be at 75. So this gets all shaded in. If I did 3 half-lives, I'd shade it in here. 3 half-lives, 4 half-lives, 5, okay? If the radioactive element in this metal is carbon-14, how much time would have passed after 1 half-life? 1 half-life is 5,700 years. Number 28, how does this cross-section indicate that Stockton sandstone is the oldest rock layer? Stockton sandstone is the oldest layer because it's at the bottom. You could say the law of original horizontality states that Stockton sandstone is at the bottom. State one piece of evidence that supports the fact that the Palisade sill is younger than the Brunswick sandstone. Here's the Palisade sill. It's super famous. It's mentioned in your reference table about 8,000 times. See it on every Regents question. Palisade sill is just an igneous intrusion. But how do we know it's younger than the Brunswick sandstone? It's because it cuts through the Brunswick sandstone and metamorphizes it. The Palisade sill cuts through the Brunswick sandstone and metamorphizes it. Okay. And then the last question, describe one piece of evidence from the cross-section that supports the inference that the fault is older than the basalt. The basalt goes over the fault. The fault does not cut through the basalt. So you could say the fault does not cut the intrusion. Or you could say the intrusion goes over the fault. All right. So please email me if you have any questions about tomorrow's test. It's going to be about 20 to 25 multiple choice questions, and I will post a little bit more review for you. Thank you.